What if your entire digital life, photos, videos, documents, memories, could be stored in a speck of dust? What if the future of computing didn't live on silicon chips, but in your genes? By the end of this video, you'll understand how a technology once reserved for nature is about to redefine everything we know about memory and machines. And that's just the beginning, because the future of memory is being written right now and you're watching it happen. The impossible is possible. DNA-based storage uses the same code that defines life: adenine A, thymine T, cytosine C, and guanine G, to encode digital information. Every zeros and ones can be translated into a biological sequence as combinations of A, T, C, and G, something like A, T, G, C, T, A, G, C, G. It's not just a theory. Scientists have already stored everything from Shakespeare to operating systems in DNA. Sounds insane, right? Instead of metal or silicon, we're storing files and molecules. Literally. I mean literally. The binary quaternary conversion. 00 equals A, 01 equals T, 10 equals C, and 11 equals G. Depending on your code, files are encoded and then synthesized into physical DNA strands. Computer storage is ones and zeros, which equals the binary code. DNA storage is ATCG, which equals the life's code. The catalog DNA in 2019 and 2020 actually stored the entire contents of Wikipedia's English version, over 16 gigabytes, in synthetic DNA. Meanwhile, in the Northwestern University in 2021 developed a DNA sticker that can store barcodes for product tracking in the supply chain. 1 gram of DNA could theoretically store 215 petabytes of data. That's like fitting the entire Netflix library into something smaller than a pencil eraser. Insane, right? Unlike magnetic or optical storage, DNA doesn't need electricity to retain data. It can last for thousands of years under the right conditions. It starts with converting your data into DNA code. Then, a lab synthesizes this artificial DNA. In order to read the data, scientists use a DNA sequencer. Yes, a DNA sequencer, the same kind used in genomics. Encoding. Scientists translate digital files into a DNA recipe made of A, T, C, and G. Synthesis. Machines build synthetic DNA strands with that exact sequence. Storage. The DNA is dried and stored in tiny test tubes, and what's interesting, no electricity is needed. Reading. When you want the data back, the DNA is decoded and converted back into digital form. Yes, DNA can degrade, or sequencing can make small mistakes. That's why error correction codes are built into the DNA data. They act like a spell checker for your digital DNA, so you can still reconstruct the file even if a few bases are wrong. It's like switching from a 2-letter alphabet to a 4-letter one, meaning DNA can pack in way more information in a much smaller space. And, unlike digital systems, there's no electricity needed to keep the information intact, which is a huge plus if you tell me. Companies like Twist Bioscience, Microsoft, and East Zurich are pioneering DNA storage. Did you know DNA can be freeze-dried and stored for centuries? Retrieval can be done through a PCR polymerase chain reaction. This all seems impossible, right? But what? If your memories could be stored in your DNA, would you want them to be? Drop your thoughts in the comments below. So, the problem is, our current storage media hard drives, SSDs, magnetic tape, are bulky, power-hungry, and degrade within decades. Imagine losing centuries of history, docs, images, etc. because the drives just gave up. Every day, we're creating more data than the day before, and we're running out of space to store it. In 2025, humanity generates over 328 million terabytes of data every single day. That's enough to fill all the books ever written, over 1,000 times per hour. But our storage methods are falling behind. Hard drives wear out, servers overheat, and cloud storage, and guess what? It's just someone else's data center storing your data. The IDC reported in 2023 the global datasphere is expected to hit 175 zettabytes by 2025. For scale, That's more than 21 times the amount of data in existence in 2016. Data creation expected to reach 181 zettabytes by 2025. Magnetic tapes, SSDs, degrade in 10-20 years, which needs to be replaced and/or fixed. Meanwhile, the CERN's Large Hadron Collider produces about 1 petabyte of raw data per second during collisions. Only a fraction is stored due to current storage limits. DNA, on the other hand, can preserve data for over 1,000 years longer than our current storage type. So the question you may ask, are we building more data centers? That's not a clean solution. They consume around 1% of global electricity and emit carbon on the scale of a small country. There are well known of use cases, at Harvard University in 2012, the geneticist George Church encoded his entire 53,000 word book Regenesis along with 11 images and a JavaScript program into DNA. University of Washington and Microsoft in 2016 successfully stored and retrieved 200 megabytes of data, including high-definition videos and hundreds of classic literary works, with zero data loss. Imagine storing the entire Library of Congress in something the size of a sugar cube. ETH Zurich in 2015 encoded the Archimedes palimpsest and an ancient Swiss federal charter into DNA encapsulated in silica projected to last more than 2,000 years. In 2019, Microsoft stored an entire music video in a test tube of DNA. In 2013, researchers encoded Shakespeare's sonnets, AI models, even JPEGs into biological strands. How creative is that? There are a ton of more use cases that you can search on the internet, from archiving for museums, governments, projects, black box data that contain the world's secrets, deep space communications, radiation proof, and preserving cultural history in biological form. Imagine storing the internet, every website, photo, video, game inside something smaller than a grain of sand. It's not ready for your smartphone just yet. Synthesizing DNA is expensive, about $1,000 per megabytes, and slow, but Moore's law once made computers affordable. The same will happen here. We're standing at the edge of a data revolution, and DNA is about to become more than just a blueprint of life. So you may ask yourself, what's being solved? Well, cost is dropping as biotech scales, new enzymatic synthesis methods are faster, greener, DNA data indexing systems are becoming smarter, and a lot more is being done. Meanwhile, the UK's Cambridge consultants are prototyping a DNA jukebox that could store entire music libraries in a device the size of a sugar cube. Major predictions occurred at the European Bioinformatics Institute, EMBO-EBI, predicts that by 2035, DNA storage could be commercially available for archival backups, replacing magnetic tape entirely. The first commercial DNA archival systems by 2030, potential for biological computer hybrids, and integration with neuromorphic chips. But with all great leaps forward, there are hidden challenges and even dangers that could shape or shatter DNA storage's future. But what if the future of data isn't just in DNA, but in you? So, what do you think? Do you believe this technology will shape our future, or are we heading into dangerous territory? Remember, DNA isn't just the code of life. It might soon be the code of civilization. In a world overflowing with data, the key to the future could lie in our past. Imagine passing down your family's entire digital history, photos, videos, journals embedded into your own genome for future generations. As costs drop in read, write speeds improve, DNA storage won't just be for scientists. It could be in your home, in your phone, or even in your wearable devices that's coming soon. And here's a wild card. DNA storage could merge with quantum computing, allowing us to store and process data on a molecular scale, redefining what's possible. If you found this mind expanding, give it a like and subscribe to The Curious Explorer, where science meets wonder. Share this with a friend who still thinks flash drives are futuristic.